Physics is the fundamental to the understanding, design, and operation of rockets. Various principles and laws of physics come into play throughout the life cycle of rocket, from launch to space travel. Here are some key areas where physics is crucial in rocket science. The first one, Newton's laws of motion. Newton's three laws of motion form the foundation of classical mechanics and are essential for understanding the motion of rockets. The first law describes inertia, the second law relates force to acceleration, and the third law explains action and reaction. Then the second one, conservation of momentum. Conservation of momentum is critical principle in rocketry. The explosion of mass propellant at high velocity generates thrust and imparts an equal and opposite momentum to the rocket. The third one, gravitational forces. Rockets must overcome Earth's gravitational force to reach orbit. The force of gravity is described by Newton's laws of universal gravitation, and it is a crucial factor in trajectory calculations. Fourth, fluid dynamics. The behavior of fluid, including the combustion products in rocket engine, is governed by fluid dynamics. The principle of fluid flow and thermodynamics are essential in designing efficient propulsion systems. The fifth one, thermodynamics. The conservation of chemical energy into kinetic energy in rocket engines is described by the laws of thermodynamics. Understanding heat transfer, combustion, and energy conversion is crucial for designing efficient propulsion systems. Sixth one, aerodynamics. Aerodynamics is essential during the rocket's ascent through Earth's atmosphere. Concepts such as drag lift and the interaction of rocket with air are critical for designing streamlined and stable rockets. Seventh one, orbital mechanics. Physics plays a key role in understanding the motion of objects in space. Kepler's law of planetary motion and Newton's law of gravitation are fundamental for calculating orbits, trajectory planning, and rendezvous maneuvers. Then the eighth one, relativity. In certain situations involving high speed or strong gravitational fields, Einstein's theory of relativity becomes relevant. While classical mechanics is often sufficient for most rocketry application, realistic effects can be significant in extreme conditions. Then the nine is electromagnetism. Electromagnetism principles are employed in the guidance and control system of rockets, gyroscopes, and magnetometers. For instance, use of magnetic principles to determine orientation and direction. 10th one, radiation in space. Understanding the effects of radiation in space involves principles from nuclear physics, electromagnetic radiation, which is crucial for spacecraft design and protection of sensitive equipment. In the summary, physics is the science that underlies the entire field of rocket science. From the base principles of motion and forces to advanced concepts in thermodynamics and relativity, a deep understanding of physics is essential for the successful design and operation of rockets.